The sixth rule here is the quotient rule. And we are using the quotient rule when we have a fractional function, when I have a fractional functions. For example, here you have y is equal x plus 1 over x plus 3. There are two terms in the denominator, so you cannot simplify it. So in this case, if you are looking for dy by dx, you should use the quotient rule. And the quotient rule in another form is vu dash minus uv dash over v square. So if the numerator function is u and the denominator one is v, the derivative is derivative of u dash multiplied by v minus u by v dash divided by v square. Let's solve this example together. Y is equal x plus 1 over x plus 3, and you wanted to find the derivative of this function. So all what you have to do is to find u and v. U is the numerator. Let me change this one to 2. And v is the denominator, which is 2x plus 3. Then you gotta find u dash, the derivative of x is 1, and v dash, the derivative of x plus 3 is 2. As 3 is a constant, its derivative is 0, and 1 is a constant, its derivative is 0. So dy by dx is equal the squaring of the denominator, which is 2x plus 3 all to the power of 2. Then u dash by v, so it's 1 multiplied by 2x plus 3 minus 2 multiplied by x plus 1. So it's equal the denominator to the power of 2. 1 by 2x is 2x plus 3 minus 2x minus 2. So the final answer is 2x plus 3 square, and the final answer in the numerator is 2x and negative 2x move together. It's 1 over 2x plus 3 square. This is dy by dx, and how we can use the quotient rule to find the derivative. Second example, find f dash, which is dy by dx, f dash, the same as dy by dx, same as y dash, same as first derivative of the function f of x is equal x to the power of 3 minus 4 over x squared plus 3. As we can see, I cannot write this function as a sum of powers of x. So I'm going to use the quotient rule. So I'm going to write u and v. U is the function in the numerator, which is x power 3 minus 4. And v is x squared plus 3, the function in the denominator. Then I find u dash and v dash. U dash is 3x squared, and v dash is 2x. Then I'm going to start by multiplying u dash by v minus v dash by u. So in quotient rule we are using subtraction. So in this case I'm going to multiply 3x squared by x squared plus 3 minus 2x multiply x power 3 minus 2, and squaring the denominator and squaring the denominator. Simplified, multiply 3x squared by x squared and 3x squared by 3, and 2x by x power 3 and 2x by negative 4. Notice that negative by negative is give me positive. Then I'm going to add the like terms. 3x power 4 and negative 2x power 4 is 1x to the power 4 plus 9x squared plus 8x. By using the quotient rule, find the derivative of y dy by dx, dy by dx. We know that the rule for the division or the quotient rule is v square u dash v minus v dash u. So I assume that u is x squared plus 3x, the numerator. and v is the denominator, which is 2x minus 8. Then I start by finding derivative of u with respect to x, so it's 2x plus 3, and the derivative of v, which is 2. So dy by dx is equal squaring of the denominator, then 2x plus 3 u dash multiply v minus v dash multiply u. Then I'm going to simplify. I don't simplify the denominator, so I don't expand the bracket. 2x by 2x is 4x squared, 16x, 6x, minus 24. Negative 2x squared, negative 6x. So it's 2x minus 8 to the power of 2, and 4x squared, negative 16 and positive 6 and negative 6. So it's negative 16x minus, oh, I didn't add 4x squared and negative 2x squared, it's positive 2x squared, minus 24, minus 24. By using the quotient rule, find the derivative of the form. The quotient rule, d by dx for u over v is u dash v minus v dash u over v squared. So we call this is u and that one is v. So dy by dx is equal x squared minus 2x minus 2 all to the power of 2. Then derivative of x minus 1, which is 1, multiplied by the denominator, minus derivative of the second, which is 2x minus 2, multiplied by the first. Then we need to simplify it. So 1 multiplied this function give me the same, so it's 2x squared minus 2x minus 2. 2x multiplied by x is 2x squared, multiplied by negative is negative 2x squared. 2x multiplied by negative 1 is negative 2x, multiplied by negative is positive 2x. Negative 2x multiplied by negative is positive 2x. And finally, negative 2 multiplied by negative 1 is positive 2, multiplied by negative is negative 2. I don't simplify the denominator, so it's equal to x squared and negative 2x squared is negative 1x squared, negative 2x, positive 2x, positive 2x is positive 2x, negative 2 and negative 2 is negative 4. So all to the power of 2. This is dy by dx.
Use the quotient rule to find the derivative of y, where y is equal to 3x minus 5 divided by 4x plus 7. We all know that the derivative with respect to x for the division of u over v is equal derivative of the first multiplied the denominator minus derivative of the denominator multiplied by the numerator and the denominator square, which is u dash u prime multiplied by v minus v prime multiplied by u divided by v square. So we assume that u is 3x minus 5 and v is 4x plus 7. So u prime, which is the derivative of u, is equal to 3, and v prime, derivative of v, is equal to 4. Now I'm going to write that dy over dx is equal the square of the denominator, 4x plus 7 all square, and then 3 multiplied by 4x plus 7 minus 4 multiplied by 3x minus 5. So it's equal 12x plus 21 minus 12x plus 20 divided by 4x plus 7 all square. So negative 12 and positive 12 give me 0. 21 and 20 is 41 divided by 4x plus 7 all to the power of 2. In question 66, y is equal 4x squared minus 2 divided by x squared plus 4, and he's looking to find the derivative by using the quotient rule. So we know that the derivative with respect to x for u over v, the derivative of u prime v minus v prime u divided by the square of v. So let's assume that u is equal to 4x squared minus 2, and v is equal to x squared plus 5. U prime, which is the derivative of 4x squared minus 8, is 8x. V prime is 2x. Now, let's apply the rule. So y prime is equal square of the denominator. Then u prime times v, so it's 8x multiplied by x squared plus 5, minus v prime by u. So it's 8x power 3 plus 40x minus 8x power 3 plus 4x divided by the squaring of v. So 8x power 3 minus 8x power 3 gives me 0, and 40 plus 4 is 44x divided by x squared plus 5 all to the power of 2. Question number 67, y is equal x squared plus 1 over 3x. I can solve this question by the method a plus b divided by c is equal a over c plus b over c, or I can use the quotient rule. First, let's solve it by split rule. So I can write y as x squared divided by 3x plus 1 over 3x. So y can be written as 1 over 3, and x power 2 divided x power 1 is x power 1 after subtracting the power, plus third x to the power of negative 1. So dy by dx is equal. Derivative of third x is third, and derivative of negative 1 over 3 is negative 1 over 3x subtracted from the power 2, which can be written as 1 over 3 minus 1 over 3x to the power of 2. This is by using the split rule or method of working, as I have only one term in the denominator. Now, what about the quotient rule? The quotient rule, I'm going to suppose that u is x squared plus 1 and v is 3x. So y prime here is 2x, v prime is 3. And we know that d by dx is equal square of the denominator, so it's a 3x squared, and 2x multiplied by 3x minus 3 multiplied by x squared plus 1. So it's equal 9x squared in the denominator, and 2x times 3x, 6x squared, minus 3x squared minus 3. So it's a 3x squared minus 3 divided by 9x squared. Notice that if you make the same denominator here and multiply up and down here by x squared, it's going to be 3x squared, and up 3x squared minus 3. And you can also divide it each term by 3, so it's x squared minus 1 divided by 3x squared. So this one is x squared minus 1 in simplest form. By using the quotient rule, find the derivative of y. And as we can see that y here represents a rational function, so the derivative of u v is the square of v, u prime v minus v prime u. U prime, it means du by dx, derivative of u with respect to x. So we assume u is x to the power 4 minus 1, v is the square of x squared minus 1. U prime is 4x to the power of 3. V prime is 2x. So y prime is equal the square of v and the product of u prime and v. minus the product of 2x and x squared minus 4. So by expand the bracket, negative multiplied by positive is negative, and positive terms. So adding the like terms, 4x to the power of 5 minus 2x to the power of 5 is 2x to the power of 5 minus 4x to the power of 3 plus 2x divided by x squared minus 1 whole square. By using the quotient rule, find the derivative of y. Derivative of y, which is dy by dx or y prime. So in case of I have a quotient, a division, so I'm going to apply the quotient rule, which is the square of the denominator and the derivative of the numerator multiplied by the denominator minus derivative of the denominator multiplied by the numerator. We assume that u is 3x and v is 2 minus x. So u prime is 3 and v prime is negative 1. So dy with respect to x is squaring of the denominator and then 3 multiplied by 2 minus x minus negative 1 times 3x. So 3 multiplied by 2 is 6. 3 multiplied by x is negative 3x. Negative multiplied by negative is positive 3x divided by 2 minus x squared. So it's 6 divided by 2 minus x all squared.